Hello, and welcome to the lab, shop, office thing. This is part 3 of my Tailsitter VTOL build by modifying an FT spear from flight test. So, first off, there's been some setbacks. Well, really one setback. Okay, 2 setbacks. So, last time, on the last video that I posted, I said I was going to have the airframe built by this point so that I could begin to modify it and mount electronics and get everything ready to rock and roll and be really well on my way to having a flying aircraft. That has not happened yet. And the reason for that is kind of twofold. So, first off, because I want this to be a build that can be broken down into smaller parts and placed into a box that's less bulky, I have to be able to disassemble this aircraft. And to do that, my plan has always been to use carbon fiber tubes as spars that can slide in and out of each other and make it so I can slide the wings off. I've got a particular mounting system, and I'll go over that in the next video, because I should have that designed and hopefully printed by then. So I had to wait for materials, I had to wait for everything to get here, but now I have carbon fiber rods. This is a mock-up of the spar I'm going to do. Obviously it's not cut down to size or anything, but it should work. Now, the second issue that I ran into was with cutting out the parts for the model itself. So, the issue I ran into was that because this is a flying wing and it has a very thick root cord, meaning distance from the front leading edge of the wing to the back trailing edge of the wing, that distance is really long on this flying wing. And so the way that this construction works is you have to fold some foam board in half over a curve to get your wing shape. So essentially that root cord, that length, is doubled for the raw material that's cut out. And because of that, it's just a little bit too big to cut out on the laser cutter that I have access to. Now, I do want to cut out other stuff for this on the laser cutter, and I may or may not be able to do that, but I'm not able to cut out the bulk of the airplane on the laser cutter, meaning I have to do this the old school way, the original way I learned how to build airplanes from flight test kits. And that is by taking the plans for these kits, printing them out on individual sheets of paper, taping those pieces of paper together, and making one giant schematic to then cut out and trace. This is one such schematic. Now, that is the schematic for the FT spear. So I've got it all taped together, it's all ready to be cut out. I just don't have time right now to cut that out because of a bunch of different factors. One of which is building an airplane for a different project that's much bigger. So, the other consideration that I've been having to work around is how do I modify the fuselage of this aircraft to be able to accept carbon spars. Because on the FT spear, you end up gluing the two wings together, like in the build video from flight test. But this center section is the bottom of the fuselage, and it's attached to the wings permanently. Like there's the seam right there, where you attach the two halves. So what I've got to do is modify that to be able to be disassembled from the wings. And like I said, I have that about figured out. What I'm going to do is I'm going to cut this center section out. I'm going to do this as a regular build pretty much, and then cut that center section out right there. I'm going to cut that center section out and use that fuselage to modify it, etc. Now, since I'm having to modify the fuselage, that's also going to take some time. But I believe in 2 weeks I should be able to get that done. Now that I have all the materials I need, or should need. That could change, but for now, I don't see that being a problem. In addition to getting the plans cut out, I have also acquired all the foam board I need to do this build. I have 5 sheets of foam board. Used to have 6, but then I built a resin printing enclosure. Well, a curing chamber for my enclosure, which I might go over in another video, who knows. But, case in point, I have plenty of foam board. I have pretty much everything I need to build this. I have servos, I have control horns, I have wire, I have a 3D printer for everything else. So, with that in mind, since I was delayed on the hardware side of things, I worked a little bit on the software side of things. Now, like I said in the first video, the software that I'm going to be using on this build is ArduPilot, specifically ArduPlane. And so I flashed the firmware onto the F405 board that I have, and it works great. The heads-up display comes up, the gyro is stable, it's looking like everything's playing nice. Now it's just a game of configuration, pretty much. And the nice thing is, with it being ArduPlane, there is so much documentation that I should be able to read the instructions on how to build a Tailsitter and do it all without having to get outside help for that. Now, there's an exception to that. There is a lot of documentation and there's a lot of things that I could miss. So, push comes to shove, I'll talk to an expert. Otherwise, I've pretty much got it. For the other part of this build, along with the ArduPlane, the way that I'm going to be controlling this aircraft is obviously with my Radiomaster Zorro, specifically using a ELRS module that attaches to the back of it. And just as a refresher, the goal with using ELRS on this build is that I should be able to update to the latest beta firmware and have a Mavlink connection over ELRS to my plane without having to buy additional hardware aside from the receiver to be able to have my laptop talk to my plane. Now, there has been a hiccup with that. ELRS Mavlink works just fine. It's a little slow. I have a coworker of mine that got to work on a system for a lab that we both work for, and it works very reliably. He's able to test things on it, able to fly aircraft. He had one of our big quad planes. Well, not one of our big quad planes, but our small quad plane that is bigger than most RC planes. He was flying that reliably off of the ELRS connection and getting a Mavlink connection to the laptop. So if that's the case, what's the issue? The issue is with the module that we're using itself. The module that I have been working with is the Jumper Aion? A-I-O-N. Yeah, I don't know how to pronounce that. Anyway, it's the Jumper AION. And it's a pretty solid transmitter, and it should have good range theoretically. It's been working fine. I haven't had any problems with it thus far. The only issue is that the original plan was to have the laptop connect to that module wirelessly over a Wi-Fi network that module would create. Now, that module can create a Wi-Fi network to update firmware and settings and things, or using ELRS's online tool. However, it does not have an additional module called an ELRS backpack that would allow it to establish a network connection for data transfer. So if that's the case, how on earth am I getting this module to talk to my laptop? Well, on the bottom of this module, there is a USB-C port. So I'll just plug in over USB. It's not ideal. It's not the most portable solution they've ever come up with, but ArduPilot has come out with a version of ArduPilot that's compatible with Android. So I'm planning on trying to see if my Android tablet with a USB-C plug would be compatible with this kind of a system. And if it is, that would mean that I could have a totally handheld GCS to run my flight ops on this aircraft. Basically meaning I can fly the plane from my tablet on its own if I wanted to, but I don't want to. I'm going to be using my controller, but it's a whole thing. Now, with all the updates out of the way, I am going to have to modify my original timeline, because my original timeline had me finishing the build of the physical aircraft a week ago, and finishing up the software by the middle of this month and flying by the end of October. Now, obviously, that's not happening, so I need to modify it just a bit. My working timeline as of right now is finish the build by the end of this month. So that means physical build 100% done, modifications done, it's able to be assembled and disassembled reliably. By the beginning of November, so like 6th or 7th, I will be finished with configuring the software. So the firmware on the flight controller itself should be configured by November. Well, by the beginning of November. And then the maiden flight should be right after that. So probably middle of November. I'm going to try to time it so that I'm not flying in the middle of a blizzard, because that would be less than ideal. Overall, I'd say this project is going pretty smooth. Just as kind of an overview of challenges that I run into, I had to wait for materials, I had to find a different way to cut out the parts that I need, and I needed to make sure that I'm going to have everything I need all at once so I'm not delaying this build further. So, as far as the big picture goes, my main problems was just getting materials. Now that that's out of the way, most of this is just going to be building and bug fixing. And in a project that's usually like 3/4 of the work. So, the next few videos should be very interesting, shall we say. In any case, that's all I've got for now. Sayonara.